Here's your Unit 5 study guide explained. Number 1, find the volume of each figure. A cone has a volume of 45 pi cubic centimeters. What is the volume of a cylinder with the same height and the same radius? So we have learned that a cone and a cylinder have a relationship. A cone, it would take 3 cones to fill up a cylinder. So if the cone had a volume of 45 pi, the volume of the cylinder would be 3 times that. Therefore, 45 times 3 is 135 pi. So as long as they have the same height and the same radius, the cylinder is 3 times bigger than the cone. And then we would say the label on there would be centimeters cubed or cubic centimeters. Then the opposite of that would be true. If a cylinder has a volume of 114 cubic units, what's the volume of a cone that has the same height and the same radius? So if we go the other way, a cone would be a third of the size. So we would take the 114 and we would divide that by 3. 114 divided by 3 is 38. And our label just says cubic units. So I'm just going to go ahead and write cubic units. And it didn't say anything about pi or anything, so I just did straight up 114 divided by 3. For number 2, we're going to find the volume of each figure and make sure you show your work. And our answer is in terms of pi. So remember, that means we don't calculate the pi. So our first shape is a cylinder. So use your formula sheet to find the formula for the volume of a cylinder. On the formula sheet, it says V equals pi r squared h. Now, to show your work, you're going to show what we're substituting in. Now, terms of pi means we are going to just leave the pi symbol. We're not going to calculate the pi. Okay, so now times the radius twice. So the radius is halfway across the bottom of the circle. So our radius is 6, but we need 2 of those. So 6 times 6. And the height of our cylinder is 7. So now I just do all of those calculations right there. 6 times 6 times 7. And do not calculate the pi because this is in terms of pi. So that gives us 36 times 7, 252 pi, and then it's kilometers cubed. All of our labels that are 3-dimensional will be to the 3rd power. And again, terms of pi, don't type in pi at all. The next one is a cone. And we're going to show all of our work. So our formula, on your formula sheet, it's 1/3 pi r squared h. And some students like to do pi r squared h and divide that by 3. Either one will work. I'm going to show you the divide by 3. Okay, again, it's in terms of pi, so do not calculate your pi. And then let's look at our shape here. Our radius is 3. And remember, you need 2 of those because it's radius squared. So 3 times 3. And the height of our cone is from the base to the top there, the vertex. So that's going to be 11. Now I'm going to do 3 times 3 times 11. And then don't forget, we have to then divide that by 3. So 99 divided by 3. Remember, don't calculate your pi. And we will get 33 pi. And this one is meters cubed. And then our last shape is a sphere. And when you check your formula sheet, it's 4/3 pi, and then the radius to the third power. Don't forget about that. Okay, so we're going to do 4/3. Do not type in the pi because it's in terms of pi. And then we need 18 to the third power. 18 times 18 times 18. So now type all that in your calculator. 4 divided by 3, or use your ABC button, times 18 times 18 times 18. And then that looks like that gives us 7,776 pi. And I'm going to squeeze this in here, meters to the third power. Okay, and that is all of them in terms of pi. And that is also showing work. Okay, moving on for set 3, or number 3 here, we're going to find the approximate volume of each figure, and this time we're going to use 3.14 for pi. Okay, so again, get in some good habits, write down all of your formulas. So cylinder is pi r squared h. And now substitute in, show the numbers that you're multiplying. So we're going to do 3.14 times the radius. Ooh, be careful here because the whole way across they're giving us diameter. We just need half that distance. So 14 divided by 2 to get us the radius. Our radius will be 7 on this one. And we need... let's see, we need 2 of those, so 7 times 7. And then the height of this cylinder just happens to also be 7. Okay, now go ahead and pick up your calculator and let's calculate all of that. And 7 times 7 times 7 times 3.14, all of that, I get 1,077 and 0.02. And remember that's yards cubed, or cubic yards. Okay, make sure you show all of that work. Okay, moving on to the cone. Okay, again, let's see, our cone here is pi r squared h, and divide that by 3, or you can use 1/3 if that's your preference. Okay, so we're going to use 3.14 for pi, like the directions say. And then we're going to times that by the radius. We need 2 of the radiuses. Okay, they did it again. They gave us the diameter. So to give the radius, we have to cut that in half. So that's 2 times another 2. We need 2 of those. And then times the height of the cone, which is 7. And then all of that gets divided by 3. So go ahead and calculate all of that. 3.14 times 2 times 2 times 7. Hit equals, and then divide that all by 3. So I am getting 29.30666. So I'm just going to go 29.3, and that is feet cubed, or cubic feet. Final answer. Okay. And then our last shape is a sphere. And so I'm going to look at my formula sheet and write down my formula. It's 4/3 pi, and then the radius is to the third power. Make sure you're doing that. Okay, then 4/3, or 4 divided by 3, times 3.14 for pi, times the radius, and we need 3 of those. Now they did it again. They gave us the diameter. So remember to cut that in half. So 60 divided by 2 to get the radius. Our radius will be 30. And we need 3 of those, 30 times 30 times 30. And then when you calculate all that, 4 divided by 3 times 3.14 times 30 times 30 times 30, you get, okay, we get a very large answer here, 113,040, and it's feet cubed. Okay, so again, just follow your formula and make sure you know what you're using for pi for all these. Show your work too. Okay, for number 4, a cylinder has a volume of 88 cubic inches, and we know the radius is 2 inches. Find its height. Okay, so I'm going to do a quick sketch here just so I can make sense of the problem. So this time I know the volume, and I know that the radius is 2, but the height, we don't know the height. Okay, so what formula do we use? Well, it's a cylinder. So V equals pi r squared h. And now I'm going to show my work. So I know the volume is 88 cubic inches. I know that I'm supposed to use 3.14 for pi because the directions said that. And then I do also know that the radius is 2 times 2 times 2. But I don't know the height. We're trying to find the height. Okay, so first I know I can simplify all of this. 3.14 times 2 times 2, and that gives me 12.56, and then times h. Now I need to get h by itself. I'm going to isolate that variable. Since this is multiplication, to isolate the variable, I'm going to divide both sides by 12.6 to get h by itself. So this is equation solving that we had done in the previous chapter. So now that gives me the h by itself. Let's see, so I have the h by itself, and then I'm going to go ahead and do 88 divided by 12.56, and I do get a bit of a decimal, like 7 point something, so I'm going to say that my height is 7. So I did get that decimal, but there's a lot of zeros there in the tenths and the hundredths place. So I'm going to think it's safe to say that my answer is 7. Okay, for number 5, we have a similar situation where we know it's a cone and we know the volume of the cone. It's 100 pi cubic centimeters and the height is 12. Find the radius this time. So since it's a cone, we know our formula. Pi r squared h divided by 3. And here again, you can use the 1/3 if you prefer. And we do know the volume. So 100 pi. Okay, so pi over here. We're looking for the radius squared. So I'm going to put that in radius squared we're looking for. And we do know that the height is 12. And we're going to divide that by 3. Okay, so I'm going to simplify on the right side of the equation. I'm going to just leave the pi symbol, but do 12 divided by 3, which is 4. So on the right side, I have pi, I have the radius squared, and I have 4, because 12 divided by 3 is 4. Now to get the r squared by itself, I'm going to divide both sides by this pi and this 4, so I can cancel those out. And then whatever I do to the right side, I have to do the left. So I'm going to divide by 4 pi. And 100 divided by 4 is 25. And that's for radius squared. So that's for something times something is 25, and it has to be the same number, or I could take the square root of 25. So I do know that 5 times 5 is 25. So therefore, our radius is just 5. For number 6, for each equation states whether it's linear or nonlinear. Linear would make a straight line when we graph it, and nonlinear would curve. And we have learned that if we ever see an exponent, if it's not in traditional y equals mx plus b form, if there's an exponent, it's going to show exponential growth, which is non-linear. So if it's in our regular y equals mx plus b form, it's linear. And even c is linear because the x is, just a regular x. And then here I have an exponent with my variable of x, so that is nonlinear. So maybe think if you see an exponent, it's going to show exponential growth, which will curve. A farm has 2 cylinder-shaped silos for storing grain as shown. How much greater is the volume in cubic feet? How much greater is the volume in cubic feet is the larger silo compared to the small one, and show your work. So let's show our work. For both cylinders, we're going to use pi equals r squared times h. So I'm going to be doing this twice. Okay, so for this shorter one, I'm going to say, it doesn't really specify how I show pi, so I could do in terms of pi, or I could do 3.14. I'm going to go times 18 times 18 times 25. So if I did this one in terms of pi and didn't type in the pi, I would get 8,100 pi. Or I could times that by 3.14 and get 25,434. So either one of those. Okay, so that's for the one cylinder. And then the other cylinder, let's see, the radius is 12. So I go times 12 times 12 times the height of 35. Okay, in terms of pi, if I don't type in the pi and just do the regular digits, I'm going to get 5040 pi. Or I can go ahead and times that by 3.14 and get 15,825.6. Okay, so this one right here is bigger. So the question asks, how much bigger or how much greater is it? So that would be a subtraction problem. If I wanted to just subtract in terms of pi, my first answer, I can take 8,100 pi minus 5,040 pi, which is 3,060 pi, bigger. Or if we just want to do the exact answers, I can take these two values and subtract them to figure out how much greater that first one is. So let's subtract those values. Okay, cylinder A and B both have the same base. Cylinder A has a height of 5 and a volume of 62.8 cubic inches, and cylinder B has a height of 6 inches. What's the radius of cylinder B? And the hint there is to use cylinder A to get that. And what is the volume of cylinder B? Okay, so a key here is definitely right in here that both have the same bases. So if I'm thinking about this, cylinder A, the base of this is the same. If I call this cylinder A, and I'm going to call this cylinder B. The bases are the same, but the height of B is a little bit taller. So the height of A is 5 and the height of B is 6. We do know the volume of cylinder A. and it is 62.8. So what I'm thinking is I'm going to have to find the radius of both figures. So let's go back to our formula sheet. We know that the volume of the cylinder is pi r squared h. We know that cylinder A is 62.8. We don't know the radius, but we do know the height is 5. So I'm going to have to use some algebra here, some inverse operations to get the radius by itself. So I want to get radius by itself, so I want to divide both sides by the pi and the 5. Maybe do that step by step. I'm going to do 3.14 for pi as well, just to kind of keep it a little simpler. So 62.8 divided by 5 and divide that by 3.14. Oh, that came out nice and neat. That equals 4 for the radius squared. So what times what is 4? It's going to be 2, which is also taking the square root to get radius by itself. So the square root of 4 is 2. So my radius is 2, and I figured that out by doing inverse operations. So going back to my original picture, the radius is 2. That means they have the same base, so the radius must be 2 in cylinder B. So now I'm going to use the volume formula again, pi r squared h. And this time, I know that the radius is 2. So times 2 squared, and the height of cylinder B is 6. So we'll use 3.14 again, because it didn't specify. So 3.14 times 2 squared times 6. All of that equals 75.36, and that's cubic inches, if I need to put a label on it. Cubic inches. Okay, so just to be clear, so the radius of B, so for part A, we should say the radius equals 2, and then the volume is 75.36. For number 8, we're looking at this graph to look at the relationship between the diameter and the volume. And the first question says, is the relationship between the diameter and volume linear or nonlinear? Well, it curves. So if it shows a curve, then it's non-linear. Linear would show a straight line. What is the volume of the cylinder when the diameter is 3 units? So I go to my graph, I go to the 3 units, and then I go up and see it hits right here, and then I read over to the left. So the volume would be 11. And then if the diameter of the cylinder doubles, does the volume also double? Explain how you know. So if it was going to be, if I doubled the diameter of 3 and made it into 6, you can see how this is growing and it's curving, so it's not going to be consistent. So I would say no, it would not double, and that's because the relationship is non-linear. And then I added another note that the graph is not proportional and not linear, so the volume would not double if the diameter doubles. Number 9, for cylinders with a radius of 2, the equation V equals pi r squared h relates to the height of the cylinder in units and the volume of the cylinder. So sketch a graph of the equation on the axis and make sure we label everything. So we're going to graph this information. Our radius is going to be 2 each time, but the height is going to change. Okay, so I'm going to show my work down in this space right here. So my first one, the height is 0. So V equals pi. It doesn't say anything about what I use for pi, so I'm going to go 3.14. But it does say that every time the radius is 2. So 3.14 times 2, and for the first one, the height is 0. So when I do all of that, 3.14 times 2 times 2 times 0, I get 0. Okay, so now I'm going to do a height of 2. And again, the radius stays the same. So 3.14 times 2 times 2 times 2, and I get 25.12 for my volume. Okay, now I'm going to continue with, now this time the height is 4. So V equals 3.14 times 2 times 2, because the radius is always 2, but now my height is 4. And that gives me 50.24. And then finally, my height is 6. Okay, so keeping with the same radius of 2, but now my height is 6. I get 75.36. So kind of seems like a pattern here. So now we have to label everything on our graph, where my x values are going to be my height. And my height goes from 0 to 6. So I can just go by ones, 1, 2, 3, 4, 5, and 6. And then the volume, I need to span all the way up to 75. So I think I can fit in if I go by tens. Okay, and then make sure we label this volume. Okay, now I just have to plot my ordered pairs that I have just created. So let me take a look at that. Okay, so my first point is 0, 0, so that's right at the origin. Now I'm going to go, my second point here is over 2 and up to 25. So that would kind of hover right in the middle there. Over 4 up 50, just a bit titch over 50. And then over 6 up 75. That's going to be right kind of in the middle. So right there. Okay, now look at what we've got here. A proportional graph. And if I connected all those dots, it would be linear. So look at our question. What happens to the volume when the height is doubled? So it looks like when the height is doubled, we have a consistent pattern going, so the volume is also doubled. And we know this because we have a linear relationship. Okay, so I fit that on the screen there. When the height is doubled, the volume is also doubled. I know this because the graph is linear and the graph is proportional. We can see that on the graph, that it is doubling. Determine if the following functions are linear or nonlinear, and explain how you know. Okay, so a couple things to look for is a consistent pattern. So to go from, I at first like to look across to see, is there something going on here? And it looks like 4, if I did 4 divided by 4, I would get 1. And 8 divided by 4, I would get 2. And 12 divided by 4, I would get 6, and so on. So, or if I multiplied everything by a fourth, there is a consistent pattern going across the table. And in addition to that, I can see the change in y each time is, it's adding 1 each time. And then the change in x is increasing by 4 each time. So it's consistent. And then another thing I could do is I could put, this information on a graph and see if it's, if it makes a straight line. So I could plot these. I could go treat them as ordered pairs. Over 4 up 1, over 8 up 2, over to 12 up 3, and this graph doesn't quite go there, but I can just visualize that, and I can see that those would also make a straight line. So that is another strategy. So this one for sure, it's consistent. I see a pattern, and therefore that one is linear. And now I'm going to go through that same kind of process with the next table. So let's see, if I go from a 1 to a 4, not really sure if there's quite a pattern that way, but there is a pattern when I go down the table. It's decreasing by 2 each time, and over here it's increasing by 2 each time. So there's a relationship that's consistent. So I am thinking that this is linear. I'm going to put it on a graph though too and just see, does this make a straight line if I graph it? And then that's some really good proof too, because then it really shows that it's a linear relationship. So over 1 up 4, over 3 up 2, over 5 to 0, over 7 down 2, and yeah, look at that. A beautiful straight line. If I were to connect all those points, and you can see that this one is also linear. So they're both linear. I saw consistency within the tables. I graphed it just to check, and there you go. Okay, now we're going to do it again. Find the total volume of the composite figure using 3.14 for pi. And it looks like this shape has been hollowed out. So once I get my 2 volumes, I'm going to subtract them. All right, the first shape I see is a rectangular prism, which is not on the state testing formula, but it's length times width times height, which we have been practicing. So length times width times height. You can do these in any order. 28 times 12 times 20. And when I multiply all that together, I get 6,720 cubic yards. Okay, so that's for my rectangular prism. And then we haven't really done a lot of these, but this is a square pyramid, like a pyramid shape. So that formula is 1/3 the area of the base times the height. Okay, so 1/3 the area of the base. The shape of this base is a rectangle, which is length times width. So I'm going to go 28 times 12, and then I'm going to multiply that by the height. Okay, so doing all that gives me 2,240 cubic yards. And because this seems like it's hollowed out, I'm going to take those 2 values and I'm going to subtract. And when I subtract those, I get a grand total of 4,480 yards cubed, or cubic yards, for my composite.